Hola guys, welcome back to my channel. Today we are going to do the mathematical methods question. So this is actually my final exam question, mathematical method subject. Alright, so let's do this question together and let's discuss about question regarding beta function and also error function. Okay, so for question B, we need to prove that the integral over here is converged to the value 42.76. Okay, so actually we can do another techniques or approach to in order to solve this integral, okay, in order to evaluate the integral. But for the purpose of this course, we need to show using the topics that we have learned. For example, the manifestation of beta function, okay, gamma function, and also error function. But for this question, you can use actually integration by path, but it is actually lengthy and also needs more steps. But for this purpose of video, I will do using beta function, okay, because this is actually we can solve using beta function, okay, because from the limit of the integration makes it possible, okay, because if we use gamma function, this is actually seems like impossible because the limit is from 0 to 3, whereas the gamma function is the limit of the integration is from 0 to infinity. Okay, for the beta, for the gamma function, the limit is from 0 to infinity. Right, so this we need to solve using beta function. So from the definition of beta function, if you still remember, so beta of mn is basically defined as the integration from 0 to 1. Okay, for example, we have a dummy variable of x to the power of m minus 1 times with 1 minus x to the power of n minus 1 with respect to x. Alright, so if you see our question over here, question B, so the question is basically the integration of 0 to 3 x cubed times 3 minus x to the power of minus half dx. So this is the differential part dx. Okay, so if you see the general formula of beta function and the question is actually quite similar. So this is x and that x. The only difference is this, the second term, okay, which is 3 minus x. So we need to manipulate first this 3 minus x. So what we can do is basically like this, x to the power of 3 x cubed. So we can factorize the 3 first. So I want to factorize the 3. So 3, 1 minus x over 3 to the power of minus half dx. Okay, so when you multiply back, you will get this, the original expression. Okay, so let me bring the 3 in front as the constant. 3 to the power of minus half integration limit x cubed 1 minus x over 3 dx. Okay, then the only difference is we have x over 3 over here, whereas the general formula we don't have. So probably we can do a simple substitution. So let me let x over 3 equals to y. Okay, then which is x is 3y, hence we have the differential form is dx is 3 dy. Alright, okay, so when we do the substitution over here, so is 3 to the power of 1 half minus 1 half integration 0 to 3. Okay, don't forget to change the limit, because when we do the substitution for the integration, we need to change the limit because this is originally in the x world, okay, in the x variable. So we need to change in the y world, okay, in the new variable, which is y. So let's do a quick math over here. So for this, okay, when when x approaches 0, okay, when x approaches 0, so y will approaches 0, right? Because from this, when you let x equals to 0 over here, y equals to 0 divided by 3, which makes y equals to 0. Okay, when x approaches 3, then y will approaches 1, because over here, when you let x equals to 3, y is 3 divided by 3, which is 1. Okay, so the new limit is, so over here x approaches 0, y will approaches 0, so the new limit is from 0 to 1. Okay, from 0 to 1, so let me erase this. From 0 to 1, so we have because we let y equals x over 3 equals to y, or x equals to 3y, so x is 3y. Okay, 3y cube. 1 minus x over 3. X over 3 is y. Okay, y. So dx is basically this, okay, which is 3 times dy. So 3, I will put in front, 3 times dy over here. Okay. Alright, so let's do simplification. So this is 3 to the power of 3. So we have 3 times 3 to the power of minus half times 3 to the power of 3. So altogether we have, so this is 3 to the power of 4. It's 3 to the power of 7 over 2, right? Okay, 3 to the power of 3, so 6, 5, 7. Yeah, 7 over 2, integration. Okay, from 0 to 1. Okay, we left with y cubed times y minus, so don't forget, alright, so I forgot to include this minus 1 half. We still have minus 1 half over there, so this is minus 1 half, minus 1 half, and minus 1 half dy. So if you compare our question over here, okay, that we have simplified, and the general formula, it is quite similar, right? It is quite similar. Okay, then we need to compare the power. So the only difference is the variable over here. So you need to remember that the x and y is actually the dummy variable, so you can use anything. Again, it is not necessarily x, it is not necessarily y, it is can be anything. It can be any variable. For example, you can use a to replace the x, you can use b or anything. But one thing you need to remember, that when you have the variable over here, for example x, the differential form, the differential part of the integration must be the same. Like if this is x, you need to have the differential form of it to be dx. Okay, and this one is y, the differential form is dy. Okay, so yeah, basically this integration is the same of the general formula, because x and y is only dummy variable. Dummy variable, you can use any variable you want because it is dummy. Okay, so this is actually, we need to find the power. What is the power of, you need to find the value of m and also the value of n. Okay, the power basically. So you need to compare, okay, this part. So m minus n, which is actually the same to 3, with the same with 3. So m minus 1 is 3, so m equals to 4, and also n minus 1 is the same as this lah, minus half. So n is minus half plus 1 is half. So yes, right, so this is actually beta 4 half, okay, equals to 3 to the power of 7 over 2. You need to multiply with what? Sorry, let me improve the way of writing. So this is actually 3 to the power of 7 over 2 integration beta of mn, which is, so this is actually beta of mn. So m is 4, n is half, like that. So if you remember, you can you can replace the beta function into the gamma function. So this is actually equivalent to the gamma of m times the gamma of n divided by gamma of m plus n. So for the case of beta for half, this is actually same as gamma of 4 times the gamma of half divided by the gamma of 4 plus half is 9/2. Okay, so gamma of 4 is basically 3 factorial, which is 6, times with the gamma of half is square root of pi. Gamma of 9/2 is basically, if you still remember, it is 7/2 times 15/8 square root of pi, like that. So this is the way of me remembering it, is basically, so gamma of for example a divided by 2, so a can be anything, sorry, a must be odd, is basically the gamma, I mean the number before it, which is a minus 2/2, okay, times with the gamma of a minus 2/2. Okay, so where a must be odd. Okay, for example, if this is 7, or sorry, if it's 9, so it's 9/2. So it is 9 minus 7, 9 minus 2 is 7, so 7/2 times with the gamma of 7/2. So that's why I wrote here 7/2 times with the gamma of 7/2, which is 15/8 times pi. Okay, so that's actually the formula that you need to, I mean the basic and also the foundation of the gamma function that you need to remember. Okay, so and then we can multiply with, don't forget we still have the constant over that, 3 to the power of 7/2. So you need to multiply with 3 to the power of 7/2. So if you evaluate this using your calculator, you will eventually arrive with the answer of 41, or okay, 42.76, right? So yeah, you can do it by yourself to insert the values into your calculator, and you will get it is 42.76, right? Yeah, 42.76. It is about, okay, not, it is not exact, so it is about this value. Okay, so it is proven. Okay, so it's very simple. So we can go into the next question, which is about error function basically. Alright, for question C, you need to remember basically the general formula for the error function. So this is actually there is a typo in this question. So it is supposed to be error function, not the complement of the error function. Okay, so it is just ERF of x, which stands for error function of x. Okay, so the error function of x is basically defined as, okay, let me write the formula. Error function of x is defined as 2 divided by square root of square root of pi, integration from 0 to x, okay, e to the power of minus t square dt. So it's with respect to t. Okay, so one thing you need to know is we can actually replace this the exponent over here using what? Using Taylor series. So I hope you still remember what is Taylor series is. So when you have f of x, a function of f of x, the Taylor series at x equals to 0 is basically f of 0 plus the derivative with respect to x at 0 divided by 1 factorial times x plus the second derivative at x, okay, divided by 2 factorial times x square plus the third derivative where at x equals to 0 divided by 3 factorial times x cubed plus dot dot dot. Okay, so we just let f of x is e to the power of x first. Then we have what? So we have the Taylor series for e to the x is basically so let x equals to 0, so e to the 0 is 1 plus the derivative of it, the second derivative and also the third derivative is the same because this is exponential function, so it is the same with the original function. So when we sub in 0, it will equivalent to 1, so it is 1 divided by 1 times x, okay, plus, so this is also 1 divided by 2 factorial is 2 times x squared plus this is actually 1, okay, this part is 1, so it's 1 over 3 factorial is 6, alright, so x to the power of 3 plus dot dot dot. So if you realize the error function is basically minus t squared, so we just put the minus over there, minus, we put here minus, so we put here minus, so minus square is basically plus x squared, right? So this is actually plus, alright, so this is minus x cubed, which is minus x cubed, right? So we have minus over there, so this is minus, okay. So our new expression is basically e to the minus x equals to 1 minus x plus x squared over 2 minus x cubed over 6 plus dot dot dot, okay. Alright, what we can do next is we let x equals to t squared, okay, because we want this to be similar with this, so that's why we substitute x equals to t squared. So e to the power of minus t squared is 1 minus t squared plus, so t squared we square again, which is t to the power of 4 over 2 minus t squared we cube becomes t to the power of 6 over 6 plus dot dot dot. Alright, so we have this, okay. We need to substitute this Taylor series into the integration, okay, into the integral expression. Hence we have what? We now have the ERF function, the error function is 2 over square root of pi from 0 to x. So we replace, okay, we replace this with this Taylor function, okay, Taylor series function. So it is 1 minus, okay, t squared plus t to the 4th over 2 minus t to the 6 over 6 plus dot 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 with respect to t dt, alright. So let's integrate the function here. So it is so it's t minus t cubed over 3 plus t to the power of 5 over 10 minus t 7th over 42 plus dot dot dot. We need to evaluate at 0 to x, right? So just sub in, so t evaluating from 0 to x is basically x, this one is x cubed over 3 plus x 5th over 10 minus x 7th over 42 plus dot dot dot. So let's check if our expression the same with the one that we want to prove. So this is the expression, is it the same? 2 over, alright, we forgot to put square root of pi over here, so there is square root of pi over here, okay. So let's see, x minus x cubed over 3 plus x to the 5 divided by 10 minus x to the power of 7 divided by 42. Yes, it is the same. So then we wrote here proven, okay, because we have proved that the error function can be written in the form of series. Okay, this is actually infinite series. Okay, alright, yeah, so we have done both questions, question B and C, okay, under the topic of special function basically. So we have beta function, and also we have arrow function. Okay, so this is arrow function, ERF, arrow function. We have solved them, and yeah, that's all from me. Okay, and I hope you can understand my explanation about this question, and until next time, bye bye.